In this video, we are going to discuss about the memory architecture and building blocks. On completion of this topic, students will be able to understand what are the methods used for optimizing the address and what is the worst case of it. So, the general digital processor. Normally, in the general digital processor, it contains an input-output, memory, control, and here you can see the data path. So this digital processor can be examined with a finite configuration device. In this digital device, that is input outputs are given to the memory. So here the memory stores the data, and through the data paths the information can be transmitted to the other blocks. So in each circuit it has a propagation delay for the transition from it can changes from the T to F, or the superficies of this combinational circuits can be occur in all the digital systems, and also it gives us gives sufficient time that will be given to the each values of the output. So here you can see the digital processor. That building blocks of the digital processor are arithmetic unit. In that arithmetic unit, it contains a bit sliced data path, that is adder, multiplier, shifter, and comparator. And memory, it contains RAM, ROM, buffers, and shift registers. Control, it consists of the finite state machine, that is PLA, and random logic and counters. Interconnect, here we use RV switches, arbiters, and bus. And this arithmetic, the information is sent to the data paths, and here you can see the data paths are transmitted to the adders, shifters, and comparators. Through that the information is fully bit sliced to the output. So finally it is carried out in a bit sliced fashion. And in Intel microprocessor, this microprocessor is also known as the central processing unit, that is brain of all the computers, and also it is made up of many household and electronic devices. So this works together to produces the major parts of the computers, and also it produces the communication between the digital systems. This is introduced because it has a limited set of the function to perform in it, and also it contains the CPU, ROM, and RAM for the logicals to add these steps in a one chip. So this microprocessor, namely, it is used to reduce the set of the microprocessor, and also this is created with the static random access memory and the dynamic random access memory chips. And the main thing is the information which we are sending is in the form of bit sliced pattern, so that the propagation delay will be avoided by using this bit sliced fashion. So bit slicing is used for constructing the processor from modules of the processor of smaller bit width for the purpose of increasing the word length, that is to make the central processing unit in a random way that can be processed in a 1-bit field or slicer. The major example of this bit slice processor is AMD 2901. So what is used means it is the methods of expressing the image in which each pixel is represented by 1 or bits of the byte. So to incorporate hidden data in any slice of 8 slices, this approach is very essential. And here also this is used in the this allows the multiple instructions or data bits to encode in a single register in an integrated data path. So these slices are a subarray of one dimensional array, and it can be completed with a single process which has a parent array, and use for the slice must be arranged in the form of equal indexes. And here you can see the worst case delay, that is linear with the number of bits, that is T adder is equal to n minus 1 T carry plus T sum. So this propagation delay is the worst case of delay with all the possible input patterns. When A is equal to 0 0 0 1 and B is equal to 1 1 1 1, that is the worst case delay. And A is if 0 to 1, then B is equal to 1 1 1, fixed to set in a worst case delay transaction. Give questions on the arithmetic building blocks. Give the propagation delay of n-bit ripple carry adder. Thank you.